This summer, I was involved in design and creation of an amazing LED artwork for the Burning Man Festival. Burning Man Festival takes place at the end of August every year in the Nevada desert, and it's really famous for some of the more outrageous LED art. And that's exactly what we created. This piece has over 26,000 LED pixels arranged in a giant 40-foot cube structure with a vibrating haptic platform at the base where you can sort of lie and experience the visuals of this amazing artwork. For those that don't know anything about Burning Man, it's a festival that takes place every year in the Nevada desert in a dry lake bed. It's an enormous flat plain with nothing but dust. And for about 2 weeks, a city emerges out of this dust that contains around 75,000 people. And they're all interested in having a really wild alternative experience, and visual artworks are a big part of that. The Apotheneum artwork breaks down into 4 main elements. Element number 1 are the LED nets. The LED nets contain over 26,000 LED pixels that are arranged as double-sided modules. That means they emit light in 2 directions. They're embedded in this open mesh that allows air and wind to pass through and gives the whole thing kind of a transparent, translucent feeling. Element number 2 is the haptic bed. This is a platform that's made up of 96 triangles that are each outfitted with LED lighting and a haptic vibration actuator. This gives the piece the ability to create tactile vibrations that integrate with the whole experience. Element number 3 is the software that drives this whole experience. It's called Chromatik. Chromatik allows you to author and deliver these experiences in a really elegant way. And we're going to be talking to Mark Slee, who is the author of this amazing software. Number 4 is the mechanical structure of this artwork. It's absolutely gigantic. It's 40 foot tall and 40 foot on a side. It's designed much like truss work that you'd use to make a rock and roll stage in a traveling rock band. It's got to be super safe, it's got to be easy to assemble, and easy to knock down and transport to a new location. So when one contemplates creating an artwork like Apotheneum, which is really basically like a very low resolution grid of pixels, it's easy to fall into certain mindsets that really limit your creative possibilities. The first mindset is, it's just a big display screen. We're just going to play some video on this and that's going to be it. That's great until you see it for the first time and you realize that at that kind of resolution, those pixels are 9 3/8 of an inch apart. Most video just falls apart completely. It requires a totally different kind of content that's made for that kind of medium for it to really work. The second mentality is, oh, it's just an array of like WS2812 LEDs. I'm just going to start writing code and create these procedural animations that will animate this thing like, old school Las Vegas signage. Sure, that works, but again, you're going off into one very limited corner that's going to have a very specific and very limited sort of aesthetic. So that doesn't work either. So what's necessary to really make this work is an approach that kind of hybridizes all these ideas and recognizes the three-dimensional nature of this piece and gives you a tool and an authoring environment that honors this dimensionality, but yet involves elements of video and elements of procedural animation, and hybridizes and combines these in a tool that is flexible enough that you can really be creative and author some really amazing stuff. And I think the results speak for themselves. In this and future episodes, we're going to dig deep into these silos of technology. We're going to explore the haptic bed, how that works. We're going to dig into the LED pixels, and we're going to explore the rigging and mechanical details of that truss structure. But in this episode specifically, we're going deep into the software with an interview with Mark Slee. So, Mark, it's great to have you here. I experienced your contribution as one of the co-creators of this thing, and I wanted to get your input on how this came to be and what was the challenge for you, and just talk a little bit about like how this got started.
Sure. I guess I'll rewind quite a bit to just start with sort of how I got into doing LED work. So my educational background was in computer science, and I'd been working as a programmer for many years. And also since my teenage years, really into electronic music, and had gotten into learning how to produce that as I was kind of a teenager in the late 90s, as things were moving onto the computer, and you could get all this amazing software to do stuff that would have formerly required big studios and all that. So I first went to Burning Man a bit later, in my mid 20s, must have been in 2009, and saw all this LED stuff was sort of just starting to appear there, kind of beginning to replace some of the fire effects. And I was just sort of ready for a new hobby at that point, or a little side project, and thought, oh, that's interesting. That's something I could totally dip my toes into with the programming background. So I started looking at what was out there for lighting software, just trying to wrap my head around how would one go about programming LEDs. And I think what I found, or the conclusion that I drew, was that most of the lighting stuff had fairly naturally evolved out of the theater world and tended to come from a perspective of we're putting on a show and we've got scenes and we've got cues and there's sort of a timeline and things need to happen at the right moments. And I was kind of thinking like, oh, that's not quite what I want to do. I had been making electronic music, I had been DJing, and I was like, I was imagining more of a just sort of like free flowing looping jam kind of thing where there's lighting effects that just sort of evolve, or maybe I can VJ them a bit, or maybe they're doing things algorithmically on their own, more in a kind of synthesizer kind of fashion. So with that approach in mind, I started by just doing a simple first project that at that time was just very basic grid of color kinetics LEDs, but I used an open source framework called Processing, which you're probably familiar with, which is very sort of lightweight programming environment for creative coding to just really, really quickly get things up and running. So um, that was my initial foray, and I just kind of implemented the protocol to speak to the LEDs at that time, and set up a basic framework for myself to be able to have just kind of the simplest animation loop that was just running, where I could animate pixels myself. And then slowly from there, I started tacking on basically just long slog of more and more features to try to get that program that I built for myself to resemble the music software that I liked using, sort of digital audio workstation software, things like Ableton, nowadays Bitwig or Logic.
So that was sort of your user interface template that you were sort of drawn to, right?
Yeah, definitely.
As something familiar and comfortable that you wanted to emulate.
Absolutely. It was that, and then the features, I guess, of synthesizers, specifically LFOs, because I found I was used to synthesizing sounds with sort of traditional, whether they were actually analog or virtual analog digital things. It was always sort of, you have your bass waveforms and oscillators and stuff, but where things often get interesting is you start adding modulation to different parameters, usually with LFO, either just sinusoidal or different wave shapes. And for me, I was just like, oh, that's absolutely going to work for light. And I would think about synthesizing a light pattern in the same way. So that's kind of what I wanted. And yes, as you said, there was a load of templates out. I was like, okay, I've used loads of synth plugins at this point, or digital audio programs. So I have a pretty good idea of how I would like to interact with that. And then
right. So you kind of come at this from the point of view of trying to move away from thinking of it as content in terms of like, we're not just playing a movie, we're not focusing on just a two-dimensional grid concept. We're actually thinking about this in terms of like a three-dimensional object space, and then a generative sort of programmatic approach to creating the visuals, if I'm understanding you
Yeah,
right.
no, that's exactly right. And I think about it, yeah, that way, that and still to this day, the software runs usually in that fashion where even if you control all the parameters, it is still more like a synthesizer actually generating the output in real time from those algorithms rather than having, a flat image or video clip that has been sort of, baked in that sense. And yeah, you mentioned one other thing, which was also crucial, which was the 3D nature of it. Obviously, when I got into this, there was already a lot of amazing programs, and still are, if you were doing 2D video and video-based VJing. Um, but that was kind of one thing I ran into where I was just realized those aren't really appropriate for sort of sparse LED displays where it's not a video screen. Often the LEDs
Right.
are not even necessarily regularly spaced. They might be spaced in totally different kind of geometry with irregular gaps and things. So that was another key thing where it was kind of niche at the time. There's getting to be more and more of these types of art pieces nowadays, of course. And a lot of people were
Yeah.
doing the video sampling approach where they're like, I'll just take a video and then I'll decide some pixel corresponds to some LED. But I found that unsatisfying. I was just like, no, it's just not a video.
Right, exactly. It's a totally different headspace to program for like a low res kind of, we'll call it a lighting grid as opposed to like a pixel array, because the experience is so different. So if you take that video based, raster concept, you're definitely going to fall short in terms of your creative abilities.
Yeah, I would totally agree with that. That's been my experience. Unless you go and try to use a video program to make videos specifically understanding that they're going to be coming through this kind of pipeline. But my attitude was then like, well, I'd rather just skip the video pipeline at that point and try to go to try to make a
Right.
tool that's more geared for the actual end deliverable.
So in either case, we're really talking about a content creator needs to be really fluid with the tool to even begin to create something, because it's almost like the language is totally different. Would you agree with that?
Yeah, I think so. And that's really where I was designing for myself in some sense, where I was like, oh, what language do I know how to speak? And I was sort of looking at it, it's like, I could either try to learn a different one that maybe doesn't feel exactly suited to this medium, or I could try to take a language that I know already and figure out how to get these lights to speak it with me, so to speak.
Right. So can you touch a little bit on the sort of the 3D quality of, first of all, this artwork it's multiple planes, some of which are straight, some of which are curved, and there's this whole concept of layering. So can you talk a little bit about how you approach that from the sort of interface design and content management point of view?
Yeah, absolutely. So I'll give a brief description. The project we're talking about is Apotheneum, which is a 40-foot cube with grid LED faces on all four sides of the cube, interior and exterior, with a 30-foot tall cylinder in the center of that cube. So the way the software works is, one, at the most basic level, the position of every physical LED is accurately modeled in the software. So it doesn't think of it as a raster or as just a set of pixels. It understands the geometry, and that model is sort of loaded into the program. From there,
And is that basically like a point cloud that's represented in a 3D space?
yes, more or less. I have the software. If you're using sort of simple geometries, it has a built-in UI to add sort of strips or grids or things like this. And if you're doing a more advanced geometry, there's a JSON-based file format where you can import and specify how you've arranged things. So it is, you can think of it as a big list of points that each has an XYZ coordinate in an absolute space. So that is understood by the program.
Cool.
And the way the rendering engine works is always taking that geometry into account. So as you draw things in code in the program under the hood, it really visits each point and says, where is this point in 3D space? Okay, given these coordinates, what should the color and brightness here be? Which is slightly conceptually different from, I think, traditional raster graphics drawing often says, I want to put a square here. So go figure out which pixels to turn blue to make me a blue square. In this case, it's a little bit, I think about it coming the reverse direction because the pixels do not fill the entire space. So you can't really just say like put a square there. There might not be any LEDs in the position you specified. So it's more that you sort of need to visit where the lights, conceptually, that's how I think about it, is I'm going to physically go to where the pixel is and then determine what should be happening in that location based upon what the effect is it trying to do visually. And then, so with the layering and so this sculpture that we're working on, has those different faces and shapes. So one thing you can choose to do in the software is decide for any given animation routine what to have it apply to. So the default would be that it just applies to all of the physical LEDs and runs that routine over the entire sculpture. But you can also define what in the program are referred to as views. And these views, that term kind of refers to looking at just a piece of the entire structure. So we had...
So that would be like sort of an orthographic projection of onto the faces?
It's more just like a subset of the model. So you could say, I only want to look at the cube portion in this view. So we're going to, the cylinder doesn't exist in this view, or in this view, we're only looking at the exterior faces. So it's as if the interior doesn't exist and we're only going to render the outside. So you can you could think of it sort of like a hierarchical tree model where you trim stuff where the whole tree would have the entire physical sculpture, every LED, but we can selectively take some out. And what you're saying about projection, not exactly orthographic projection, but you could say, through what geometry do I want to look at these things? Do I want to look at them in their absolute position? Or say if I'm just doing faces of the cube, do I want to treat each of them as if they're forward-facing sort of XY plane, rather than thinking, oh, one's facing to the left, one's facing to the right. So some options like that to sort of decide how the animation is going to treat it. And so but from that comes a lot of possibilities, because you can then sort of mix and match. In the Chromatik software, there's loads of different animation routines, but they can then be blended, combined, transitioned between. So you can have a modest set of different animation routines, but then by combining, mix and matching across these views, you get that sort of combinatoric explosion where the number of possible combinations is way, way more than the number of ingredients you were beginning with. And that's what I like to explore a lot in my work, is sort of especially the combinations between them when you're going from one animation routine but blending into another one. There is where I sort of mixed concepts from, as I described, the music software world, but there's obviously a lot of well-established patterns in visual software, whether that's sort of a image editing Photoshop style thing, or VJing software, but basically the idea of having a stack of visual layers with your standard sort of compositing algorithms. So either adding color values together, or masking color values, or dissolving between them, or having opacities between things. So that's where those two concepts that's where they meet in the middle, which also is very analogous in my mind to audio DJing or mixing, where you have your standard sort of studio mixer with different faders and multiple channels of audio going at the same time. So I kind of just thought of that as, well, that's fine. Those can be channels of light that are going at the same time, and then those can be blended between and modified.
And I noticed there's a great deal of integration. I'll call it like parametric integration between the audio portion and the visual, because that's obviously really important from the experiential point of view, that there be the ability to have synchronous kind of cause and effect things where the visual and the auditory parts are really harmonious. Can you talk a little bit about how that works? Because I found that really interesting.
Yeah, in this, for a lot of the material prepared for Apotheneum, that was done at a very sort of deep level, because most of the artists working on this brought their own audio material to their pieces, and then were able to really sort of deeply choreograph the lighting effects. So the most basic way is you just have the audio waveform, whether that's coming from, whether it's yours or coming from a DJ set, and then you're trying to just react to the audio.
Right. So it's basically like either an envelope tracker or some kind of, let's say, spectral analysis
Yeah,
of the
exactly.
content.
The two basic one, yeah. The bread and butter is either you're following amplitude or you're doing frequency binning and grabbing those.
Right.
I find I have like strong opinions about this, because I often find that not super satisfying, and I think the main reason is that like our brain's perception for light and sound are just operating on two really quite different timescales. Even though it feels like we experience them fluidly, but like drums or a piano or any melodic instrument, the envelopes and transients are happening in a matter of, we're sensitive to sort of like 20, 50 milliseconds kind of thing. But in light, if you think, I mean, if you're doing 60 frames per second, which is usually beyond, so that's, beyond our threshold of perception for smoothness, that's 16 milliseconds per frame. So you're talking about a musical event can happen, and that might just be only 2 or 3 visual frames. That is not often a pleasing effect. That it rapidly degrades to sort of flashing or strobing. So what I often really try to encourage is what I call sort of, rather than audio analysis, sort of like musical analysis. And if you're working with your own composition, where you actually understand the notes that are being played or the timing of when things are happening, what I often try to do is have that trigger at the correct moment a lighting effect that evokes the right feeling or has the same sort of, it gives the same sensation as the sound, even if it actually might be quite different shape than the audio. So for instance, a big drum sound finishes really quickly, but if you hear some massive bass drum or sort of explosion sound, it makes complete sense to you to see a visual sort of explosion that might last for a second or two, even after that big impact. So I definitely explored a lot of that in my work, and I think that's what sort of most of the artists were doing. There's some tools for the Chromatik software to integrate either with a DAW like Ableton or other sort of sequencing programs, where you can just basically send trigger and either via MIDI notes or via OSC triggers that will then fire off. Within the chromatic lighting environment, that can trigger its own sort of envelopes or just modulations that respond to the audio. So that's kind of I think where a lot of the most pleasing effects come from that. Or one other approach, we had a couple live musical performances or DJ sets that were done out there, and for those were all sort of in the electronic music realm where there's a fixed and understandable tempo. So for those, we had built in the software system where it is tempo aware. There's like a master tempo in the lighting program that then, so underneath that, you can then build sort of systems of oscillators or envelopes that are synced and looping to that master tempo. So as long as you can then connect some kind of master clock signal, you can then just sort of naturally drive a visual program that will be just sort of implicitly following the rhythm of the music. And then it's up to a VJ to, obviously just make the sort of curatorial selections in a performance of how to use that.
Right. So and that is done by, well, obviously there's processing the audio signal itself, and then at a lower level, or should I say a higher level, there's the cross communication of, like, let's say you have a synthesizer with like an LFO that's sweeping something. If you can drive that signal and recognize it as a meaningful input within your software, is that part of it, or is that going too
Yeah, no,
far?
that's absolutely it. And so the performance on Friday night, that the musical performance from Foss, and Dan Ovid was running the lights for that. So they did exactly that. Foss, they had some synthesizers, sort of
Hmm.
modular control voltage system that they were using. And Dan, I believe, had found a module that can take some CV inputs and just bring it into software. So he did
Wow.
exactly that. So the Foss guys had a sort of master clock, just like a CV click pulse that I think was probably also their kick drum or something, but the basic steady beat. So Dan basically just brought that. He just took a patch cable from that into his little converter, and that basically gave him the clock. And then he had that sent into the lighting software as an OSC message that was in real time, just following the tempo. So
Yeah, no, that's fantastic, because that removes so much ambiguity and monkey business. You have the real straight data to process without any worries of contamination or misinterpretation along the way. That's
yeah,
fantastic.
absolutely. And it frees him as a VJ in that scenario to not be thinking about that synchronization part during the performance, but rather just thinking about the creative choices of like, okay, well, the sync's there.
Right.
What should the colors be now, or what kind of shapes should be showing, or that kind of thing. So yeah, also a nerve-wracking approach with that much gear, but it was pretty cool. And I think it seemed to work out really well for them. So um, the typical setup would usually just be you actually have a software running, and the software to software communication is usually less stressful, perhaps. But it was really cool to see them find a way to integrate a full hardware setup.
Yeah. Yeah. Given the context of that situation, I would say that was a brave thing to do.
Everyone was nervous, yeah, but it worked out good.
Yeah. It really was awesome. Yeah. I mean, just looking, objectively at the piece and experiencing the sound, there is definitely a fully immersive feeling to the whole experience. And, we haven't even touched on the idea of the haptic floor, which obviously is integrated in that. And I know you had a channel for that output a DMX signal compatible with the floor electronics. And, I don't think we really got too far with that, but obviously that's another layer that we can look at exploring deeply with that piece.
Yeah, absolutely. And the way you designed that, there was sort of nothing that prevented the software from conceptually just thinking of it as more lights, in the sense that it had an intensity
Right.
axis. So for that, what we did was modeled it in the same way. That view system that I was describing, sort of breaking out cube versus cylinder, did the same thing, or basically just set up a view that, okay, well, this view is actually motors. In the software, on the rendering on the screen, it just represented them as light, so you could sort of just understand the intensity visually. But yeah, I mean, similar to you had built obviously your own sort of control board that had algorithms baked in to drive the haptics, and conceptually it's really the same thing, actually. I mean, the way Chromatik
Right.
works is the exact same sort of mental model that I think you had brought to it yourself in hardware. So
Yeah. What makes me, I get excited thinking about the idea of how extensible this whole concept is in terms of adding even more layers of experiential hardware to the thing, that, the sky's the limit, really, in terms of creating a totally like comprehensive immersive experience that's all driven by this master engine. It's a very exciting concept there.
yeah, I feel the same way, obviously, probably. But yeah, no, I
Yeah.
think having like used and looked at so much, professional media software over the past couple decades, or however long, I think for me, it's most of them I can usually be, if you think of them just in terms of parameters and modulation over time, most of them you can find a way to map that concept to somehow. It'll
Right.
sometimes be slightly restrictive, but that's, I think, when I set out building my software, it was really trying to keep that at the center of it, and sort of not avoid doing things that were too particular or nuanced, or sort of niche, perhaps, because sort of like that model should have legs for most things, and then where needed, if you have something very particular, something that comes up on some other projects that use this software, it's like, oh, we also have some lasers, and we want to control those. And it's, I was like, okay, great. Like, I'm not going to build in sort of hardware laser control to this software, but if we're talking about having a way to synchronously communicate some parameter values, some colors, and some intensities, we can totally build a channel for that, send it, and then hook that up to some
Right.
professional laser software that will control a physical laser from that.
Something that will just a layer of interpretation that makes it all
Right.
work.
Similar to your control boards for the haptics, which is like, okay, well, this needs to actually run a motor under a physical thing, but that piece can live just across the border over there, closer to the hardware.
Right. Now, I want to drop down a little bit to the sort of hardware level, because the other thing that I'm going to do is I'm going to kind of go into in another video the sort of hardware and the design aspect of the physical LED hardware. And I just wanted to get your comments about the complexities there in terms of interfacing your software with this network of LED controllers. I imagine that it's fairly straightforward. You want to comment on that?
Yeah, no, I mean, it's getting easier and easier. I think since, I did my first LED project, it must have been 2010. So it's been a solid 15 years. The industry is pretty much standardized at this point on either ArtNet or streaming ACN, which is kind of an encapsulation of the same thing, all sort of an evolution of DMX, but just adapted for modern Ethernet networks. So more or less, I find that it's increasingly plug and play these days, and there's a lot of hardware controller options that are going to speak one of these protocols. So in Chromatik, I implement most of them. There's ArtNet, streaming ACN, one called DDP that's a little bit less common, but shows up a fair bit. And then there's a proprietary color kinetics one for that gear. I think that's mostly the list. And then it's sort of, if you need to implement your own one for some reason, you can, but generally would say that's a bad idea at this point. Just use one of the existing ones. But no, it's really nice because nowadays it is pretty much grab some Ethernet switches, come up with a sensible Ethernet layout, and then pretty straightforward.
Yeah, I mean, now with the gigabit switches, like, it didn't seem like bandwidth was even ever a consideration in terms of this project.
No,
anyway.
high-level bandwidth is always fine. The only place I find you do have to be careful sometimes is just in the LED controllers themselves, because a lot of those, they usually many of them kind of have mini switching capability built into them. But I find that you have to be careful because they're not always really like an Ethernet switch. I think a lot of them they're usually microcontrollers, and a lot of them I think end up doing the packet forwarding on the same microcontroller that's also servicing. So sometimes it's just being careful with that, or making sure that checking the specs on the manufacturers.
It's kind of just getting out of your own way. Like, just don't ask too much from the wrong thing.
Exactly. Yeah.
Makes sense.
One piece that I think is still that I consider not like solved by the industry yet is the color reproduction. Most of the physical LED strips tend to use 8-bit per RGB channel color, but more and more are coming out now that have 12 or 16. What I would love to see is better sort of gamma correction and dimming control done by the hardware itself. You often in software end up needing to kind of change the response because the way those physical LEDs respond is just so different from like a computer monitor or the way a digital display or television would do it. I would love to see more in terms of your comment about like let each piece do the right thing. In my dream world, software would just send colors conceptually in the sort of same way that your computer has a color space. There's well-defined color space representations of like what these bits should mean in terms of actual color. I find that most of the physical LEDs are pretty far off actually delivering that. I would love to see more of the controllers or chips themselves actually do that kind of translation, sort of understanding how the physical LEDs actually behave and sort of changing the bits either with lookup tables or whatever it is. That's the only bit I
Right,
find myself
exactly. Like,
complaining about that. Well, I don't complain about it that much, but it tends to be a tougher bit to manage. Because the way it is now, you usually end up having to just trade off a bunch of dynamic range. Typically, the LEDs get bright real fast in the low values and then continue to get brighter, but not as noticeably to the human eye. So if you want smooth response, you usually end up needing to sort of gamma correct down into using the lower bits more, but in doing so, you've just lost a lot of sort of brightness resolution by doing that. You're not really getting anywhere near
right,
8 bits of, and so that'll either manifest as sort of visual stair stepping that you can actually see, or as just a like muted brightness response.
right. Yeah, that's kind of like the final frontier in terms of squeezing every last drop out of the performance of an LED is a really good gamma curve that's matched for the exact circumstances that gets you the best color depth and resolution there.
Yeah.
Absolutely.
Another solution on this project and another good solution often is just physical diffusion. We had the sort of white plastic diffusers, and that I find often compensates fairly well. I mean, you can also then just run stuff brighter, and the diffuser naturally softens it, so you
Right,
don't the human eye is no longer experiencing that sort of like blinding, intense raw LED
right.
experience.
I think that's one of the things that made this piece really good is that we use those hemispherical diffusers, so the emission angle
Yeah,
is really 180 degrees. Because when you view this piece, you're obviously going to be always looking from oblique angles at these pixels. So having enough brightness to really juice those up made the piece magical. That's how I felt about it
yeah,
anyway.
definitely. No, I think it really benefited from having those put on. And it was fun for me actually. The inside outside thing, yeah, I had to add a software feature for that, which was good fun because I had just been rendering LEDs in the software as just a sort of omnidirectional dot. But the sort of the inside outside nets forced. I was like, oh, okay, I finally got to go actually implement some sort of directional fall off and have a concept of which way the light's facing. So that's something I'm
Right.
curious to. I've generally just focused on LEDs with this software since that's what it's geared towards. But I do constantly get requests to build in proper sort of models of like DMX lights or spots or moving heads and things. So we'll see if I one day get to that. But yeah, there is a whole nother landscape that opens up there when you think about this. Yeah, directionality of light and viewing positions and different experiences depending upon where you are.
Right. Well, Mark, this has been super interesting. I really have to thank you for taking the time to give me this juicy download on this project.
Absolutely. Always happy to talk about it.
So I hope you enjoyed that interview and this project. If you're interested and you have any more questions, hop over to the forum at hub.fernikes.com. We're going to be hosting a whole section about this project with different silos for each aspect of the project. And if you want to ask Mark a question, there'll be a great place to do that. So again, thanks for watching. Subscribe to Leo's Bag of Tricks. Have a good one.